Hello, students, and welcome to our May 4th lesson. It's going to be a little bit brief because we have to go through some SBAC instructional stuff today, but we will have our do now, which is a prompt about conflict, and our objective will be to graph quadratics, but we're going to stretch this out over 2 days. So we're going to complete the do now. We're going to complete maybe 4 or 5 problems. Actually, I'm skipping the exit ticket because it's too much to do today. But you will submit your work on Teams, and if you're in person, I will come around and see what you've done. So I will tell you what to upload into Teams. You'll see that when you go to assignments. For homework, I only want you to do number 1 to 4 of homework 2. So listen, tomorrow, Wednesday, it's SBAC for distance learners only. You will not sign into a meeting. The SBAC students will sign into a meeting. The non-SBAC students, the in-person students, will not have a meeting, but you'll complete an assignment, and it'll be more of what we're doing today. So this do now is about why conflicts escalate. What can cause a minor disagreement to escalate into a major conflict? Oh, major conflict. Is it possible to recognize the signs that an interaction is directing into the danger zone? So think about, what do you feel? I get like my shoulders tense up, but let's talk about that. How about a sentence or two right there? So today, now you've done your do now, take a minute on that and then pause the video and then come back. We're going to graph some quadratic equations, okay? We did this a little bit in class Friday just as an introduction, but we're going to actually flesh it all out now and really take our time with it. So we've got these steps. First, we find the axis of symmetry, which is negative b divided by 2 times the a value. So you want to identify the a and b value in your quadratic. Then you want to find the vertex, which means you will substitute x So we're going to substitute the x value. Then you're going to put the vertex in the middle row of a table and fill in a table of values. You can use a calculator when you do this. Then when you get those ordered pairs, because you're going to have an x value and y value, so these will be your ordered pairs. And when you get those, just plot them on the grid and connect them with a smooth parabola. So our directions ask us to graph each quadratic equation using a table. We will identify the axis of symmetry, the vertex, the domain, and the range for each one of these quadratics. So we start with a really simple parent form of the quadratic, which is y equals x squared. So our a value is 1, our b value is 0. So we're going to do, remember, it's negative b divided by 2 times a, and that will give us our axis of symmetry. So we have negative. Now 0 is neither positive nor negative, but for the purpose of substitution, we'll put it there, divided by 2 times 1, which equals 0. So the axis of symmetry, x equals 0. So the vertex, we're going to substitute in the equation y equals 0 squared, which is going to give us y equals 0. So the vertex, the x value is 0 and the y value is 0. So let's put that in the middle of the table of values, 0, 0. And we're going to evaluate for negative 1, negative 2, 1, and 2. So if we evaluate, so it's basically a matter of substitution, right? So where x equals negative 1, y would equal positive 1, because negative 1 times negative 1 is positive 1. Where x equals -2, then remember that -2 goes in parentheses, so y would equal a +4. Where x equals 1, y would still equal 1, and where x equals 2, y would again equal 4. So we have 5 points, so let's go ahead and plot them. We have 0, 0, 1, 1, and 2, 4. We have -1, 1, and -2, 4. So there's our parabola. We're going to connect it with a smooth line, adding arrows at the end. So the domain for this, because we assume these arrows go on forever along the x-axis, so the domain for this would be all real numbers. But the range, remember, this is the point 0, 0. That's the minimum. So the range is going to be all those values of y, so that y is greater than or equal to 0. So let's do number 2. We have y equals x squared plus 2x minus 1. So the first thing we want to do is find the axis of symmetry. So our a value is +1, our b value is +2. So when we insert that into our formula, we have x equals -2 divided by 2 times 1, which is -2 divided by 2, which equals -1. So our axis of symmetry is -1. So let's find the vertex by substituting. So y equals -1 squared plus 2 times -1 minus 1. And when we evaluate that, y equals 1, because -1 times -1 is 1, minus 2 minus 1, and together y equals -2. So the vertex is -1, -2. So we'll put that in the middle of the table and we'll fill in the rest. Let's do -2 and -3, 2 and 3. And when we evaluate, by inserting -2, we'll start here. We insert -2 for x. We have y equals -1. When we insert -3 for x, y equals a +2. When we insert a 2, let's do 0 and 1. Okay, when we insert a 0, y equals -1. When we insert 1, y equals 2. So let's graph those points. So we'll start with, we could start right here, -3, 2, -2, 1. Oh, that's -2, -1. -1, -2. That looks like our vertex. 0, -1, and 1, 2. There it is. Let me get a lighter color to draw the parabola. It's a skinnier kind of parabola than we've had. So the domain is definitely all real numbers, and the range is such that all the values are greater than y equals, this is -2. Okay, so y is greater than or equal to -2. Right, let's go on to number 3. So we've got y equals negative x squared minus 8x minus 17. We have a negative a value, so our a is negative 1, and our b value is negative 8. So we already know from this, that negative sign, that this parabola is going to open downward. So let's find the axis of symmetry. So negative b, so that's negative, negative 8 divided by 2 times the quantity of a, which is negative 1. So that equals positive 8 divided by negative 2, which equals negative 4. So the axis of symmetry, x equals negative 4. And we're going to substitute negative 4 and find the vertex. So negative 4, that would be, let's change our color. That would be y equals negative, negative 4 squared minus 8 times negative 4 minus 17. And when we evaluate all of that, y equals negative 1. So our vertex is the ordered pair negative 4, negative 1. So let's put that right in the middle. And let's evaluate this for negative 5, negative 6, negative 3, and negative 2. And when we evaluate those, so in other words, when we insert negative 5, we're here where negative 4 is, okay, when we insert negative 5 and we evaluate that quadratic, y equals negative 2. When we substitute negative 6, y equals negative 5. When we substitute negative 3, y equals negative 2. And when we substitute negative 2, y equals negative 5. So you can see the curve of the parabola forming here. So we said this was a downward curve. So let's graph negative 6, negative 5. So 1, 2, 3, 6, right there. Negative 5, negative 2. Negative 4, negative 1. 1, 2, 3, 4. Negative 3, negative 2. There we go. And negative 2, negative 5. So you can see that parabola form right there. And I will connect that with as smooth a line as I am able. Okay, and we have that maximum. So the vertex now, it's not a minimum, it's a maximum. So we have that domain. This graph will go on to negative infinity and positive infinity. So the domain will be all real numbers. But the range would be all the values of y such that y is less than or equal to negative 1. So the parabola is going down in this direction. So let's try a couple more. I hope you can try them on your own and come back to the video. That would be good practice for you. The number 4 says y equals negative 2x squared plus 4x plus 1. So our a value is negative 2. So this parabola is going to open downward. Our b value is 4. And let's find the axis of symmetry. So that's going to be x equals negative 4 divided by 2 times negative 2, which would be negative 4 divided by negative 4, which means x equals 1. So the axis of symmetry, x equals 1. So now the vertex, I will make that substitution. I'll put the x equals 1 into this quadratic. So that gives us y equals -2 times 1 is -2 plus 5 plus 1 equals 3. So the vertex is the point 1, 3. So we can put that right in our chart right here. And let's evaluate at 0, -1, 2, and 3. So when we substitute y equals -2 times 0 squared plus 4 times 0 plus 1, that's easy to see that we get a 1. When we substitute -1, the value of the function is -5. When we substitute a 2, the value of the function is 1. And when we substitute a 3, the value of the function is again -5. So let's graph that. So that's -1, -5 right there, 0, 1, 1, 3, 2, 1, and 3, -5. And we'll connect that with a smooth line. So this is, as we see, a downward facing quadratic. We've got that vertex of 1, 3. Our axis of symmetry, you can see, is actually here. Y equals x equals 1. Right there, right through. There it is. So the domain is all real numbers, but the range is all the values of y such that y is less than or equal to 3. So you can see that when you have a downward facing parabola, y will always be less than or equal something. When you have an upward facing parabola, y will be greater than or equal to something. So let's do number 5, and that'll be our last one for today. So our a value is 1, our b value is -6. So let's find the axis of symmetry. So that would be -6. Be very careful with those negatives. 2 times 1. So that would be +6 divided by 2, which equals 3. So our axis of symmetry, x equals 3. So let's evaluate for the vertex. So we have y equals 3 squared minus 6 times 3 plus 11. So that would be 9 minus 18 plus 11, which equals 2. So 9 plus 11, that's 20 minus 18, so y equals 2. So the vertex is 3, 2, and we'll put that right into our chart right there. And so let's evaluate this we can just go ahead and do 1, 2, 3, 4, 5. And when we evaluate this function for x equals 2, then y equals 3. When we evaluate this function where x equals 1, then y equals 6. When we evaluate this function for x equals 4, then y equals 3. And when we evaluate this function for x equals 5, then y equals 6. So you see that pattern of the parabola forming there. So let's go ahead and graph this. So we're graphing it 1, 6, 2, 3, 3, 2, 4, 3, and 5, 6. And you can see the shape of the parabola already taking shape in front of us. So, and there's our vertex, which is the point 3, 2, and that is a minimum because our parabola goes upward. The domain is all real numbers, and our range is going to be values that are greater than or equal to 2. So I think that's enough for today. We'll finish these up tomorrow, and then we'll look at a graph and analyze it from beginning to end. Try to do, let me show you your homework. I'd like you to try to do number 1 to 4. That's all I've put here for your homework. If you have extra time later, I put some fun stuff there for you as always, and I have the solutions for last night's homework as well. So keep working hard. Listen, it's quadratics now, okay? It's can get a little difficult, but stay with it. Stay with it. Do your best. Work hard, because as you do, you will be great.